All right, cool.
Okay, so let me just set it up. Oop. All right, cool. So this will be about 6 to 8 minutes long, and then we'll have a Q&A at the end. If you want to ask questions as you go, just drop them in the chat. We'll get to them at the end. Yeah. All right, so welcome to the ROV VR breakout room presentation. My name is Ever. I worked on this project with Amy, Callie, Erica, and Nathan. And this project was a joint collaboration between Olin College of Engineering, the Dassault Systems Foundation, and the Monterey Bay Aquarium Research Institute, or MBARI. And the Dassault Systems Foundation sponsored this project, and we, the Olin team, worked really closely with MBARI to bring it to life. So as a brief reminder of the motivation for this project, this is what the current control room for MBARI's ROVs looks like. There are a few pain points with it that we'd like to tackle. And so one of them is that there are limited scientist-pilot communication tools within the control room for them to be able to collaborate effectively. There are all of these bulky, fixed 2D displays. So if anyone wants to try, if you want to customize anything, if you want to personalize anything, if you want to change them for different scenarios or different missions, it's not going to happen without a lot of time and effort. And then it also requires a significant cognitive load just to be in the space and to operate the control room. And you can already just get a sense of that just from looking at it. Like there's a lot of stuff going on here. And so the goal of our project is to integrate virtual reality into ROV piloting in order to alleviate some of these pain points, as well as to bring ROV piloting technology up to the cutting edge. And I'll pass it off to Callie to talk a bit more about some of the different features of the prototype that we built and go into a bit more detail about how we tackled some of these pain points.
Thanks, Ever. So our solutions to the previously mentioned pain points were primarily live stereo footage for depth perception, 3D overlays for easily accessible data, hand-based UI controls for intuitive use of the system, and multi-user support to facilitate pilot-scientist collaboration. These solutions are typically not possible or are far bulkier outside of virtual reality. One of the challenges with the existing control room is the underwater manipulation of the ROV. Screens don't provide any depth perception, and without a sense of depth, it can be very difficult to capture different specimens for study. But MBARI has recently developed a stereo camera system for their ROVs. Using the system, we can pipe the ROV footage from the stereo camera into the VR headset. This lets pilots actually see the deep sea through the ROV's eyes. And using VR, pilots can experience flying the ROV as if they were actually inside of it and looking through a window instead of at a screen. Pilots inside this immersive environment still need more data. By porting over functionality from the existing control room, we can help keep the pilot informed and in control. Our 3D overlays allowed pilots to maintain ambient awareness of the ROV through on-screen displays in easy to see or easy to access locations. Features included things like clump delta, depth, heading, and auxiliary cameras all on our curved UI, which allows the placement of overlays around the user in a cylinder. This user-centered application is more immersive and increases the available screen space for current and future data overlays. We can also use different planes inside of VR, like the floor plane or a spherical plane. We've only experimented with spherical, but we've put things like our turns overlay on the floor plane, so pilots can actually look down to see how much the ROV is turned. And finally, virtual reality makes 3D overlays not only possible, but preferable. We took advantage of this when making the heading and attitude displays. These are all cool applications, but what makes them even more useful is that you can move them within our application. This brings us to the hand-based user interface controls. While pilots can't control the ROV through our application yet, they can control and maneuver just about everything else. Pre-dive, the Skybox stereo camera settings are easily altered using VR controllers. Mid-dive, overlays and settings can be changed using VR controllers or hand controls. Hand controls are useful because it just uses the pilot's hands instead of additional controls that they have to hold on to. This is better for pilots who already need to keep track of their joysticks for controlling the ROV, and any additional controls would be confusing and easy to lose. Using the hand controls, pilots can easily change camera settings and overlay placement settings during the dive. Once camera settings and overlay display locations are changed to their preference, pilots can save their personal settings within the application under their own name to be reloaded at a later time as pilots either change shifts or go on different missions. The emergence of individual settings wasn't previously possible with the original control room's immovable screen displays. Using our application, additional settings and new features can be easily added and changed in the future as needed without any additional required hardware. One benefit of virtual reality is that everyone can get their own view. One drawback of VR is that you cannot see your peers in the control room with the headset on. For example, a scientist may want a pilot to follow a fish she sees on the video feed by pointing at the screen. So to combat this issue, we created an additional desktop app for scientists to use without the VR headset, in which they can point at different objects on screen using a virtual laser pointer that pilots can see and react to within their own environments. And now Ever will take you through how we tested all of these things.
Thanks, Callie. So here you can see an image of MBARI's 1 million liter saltwater test tank facility. This is where they test all of the different hardware and software components on their ROVs before testing them out at sea. And this is also where we tested both our VR application and our desktop application. So here you can see some more images of how that tank testing went. So in the top left, you can see the ROV inside of the tank, and you can kind of see Ben, one of our pilots, in the top right corner. You can see them a little more clearly in the right image. And we got all these different pilots to actually try out the software that we built and give us feedback. And a lot of them were really excited to actually not just pilot it inside of the test tank, but at the idea of taking this out to sea and having this be just the way that they pilot the ROVs now. And then the bottom left, you can see an image of us all on Zoom working together with MBARI to kind of go through different bugs and squash them out and make sure that the application was functioning properly, as well as collecting feedback from pilots as they tried out the application. And so that takes us to the next steps of our project. So in the short term, MBARI is going to take out this application out to the deep sea and actually test it and see how robust it is underwater. And then the Human Robot Interaction Lab at UC Santa Cruz is going to do some user testing to see how well this actually impacts task performance. The pilots like it, but is it actually making performance more efficient or making things faster and that kind of thing? And then the development of this application may inform the design of MBARI's next-gen ROV ship and the design of the new control room, mainly around designing it around VR instead of designing it the way that the current control room was designed. And then in the long term, this application will have full AI, VR, and multi-user integration, and it can be used for creating next-generation AR and VR educational and outreach materials to get the public excited about the oceans and ocean exploration. So thank you for listening. Please stick around for Q&A. And if you have any questions, feel free to unmute or throw them in the chat and we'll just start tackling those.
Could we hear more about the development process? I mean, I'm just curious. I mean, were you able to work with an existing VR platform, or did you have to develop this all from scratch?
Oh, yeah, of course you can hear about that. So we actually used something called Unity, which is basically an application that's used a lot for making video games is the main use. But that's really nice because it's actually very well documented, and it has all of these different like VR and AR tools just built in already. And so really the challenges of our project were to get everything into Unity and then to develop the tools inside of Unity so that it would actually be able to like display all of this data and display these videos. And we had to write some custom software for things like fusing the two camera inputs into one skybox inside of the application. But Unity really helped with just giving us almost like a VR environment to start with, like a blank canvas, and then we added things in from there. And anyone else on the team can feel free to add on to that, because there's definitely a lot there.
I know this is beyond the scope of your project, but have you thought at all about how controlling the ROV in VR might look? Is it just like holding onto joysticks while they're in VR, or is there any more?
Yeah, there's a little bit of that. So here's on this slide. So all of those controls were completely unrelated to our application that already existed. We just kind of changed how pilots take in all this data. But you could totally use VR to basically, instead of having this, a control box, you could have like a VR controller, or even just use your hands. As we showed earlier, they're the hand-based controls, and that actually just uses like the pilots don't have to hold anything to use that. It's literally just the computer vision looking at their hands and reconstructing them in the VR space. So you could totally use that to actually control the ROV. It would just be a matter of figuring out if that's a good idea, and then what are the data pipelines you need for that.
And something else I'd add to that is, I think there's a pretty interesting question of, I guess, as Ever mentioned, sort of like what controls would actually work versus what sounds cool in theory, right? And I think part of what the UC Santa Cruz research group is going to do is kind of unpack that. So it's sort of like in theory, what's going to happen if we did try to implement these controls in VR, like what would be cool and flashy, or what would like work in practice? And I guess what other interaction methods have we not really thought of that were limited by physical hardware, but if we could just like do away with the hardware and only had hands, like I guess thinking of that within that frame, what types of controls could we use with just hands alone? Or I guess things are related to that.
And then I think some of the photos you were showing, it looks like the ROV was, like you weren't looking at the camera on the ROV, you were looking at the ROV from a different camera. Does the ROV have a camera on it, or can you see the world from the viewpoint of the ROV?
Yeah, so that's actually what this VR camera in the bottom left is. So that actually gets mounted. In the image, it's a little hard to see, but it's actually mounted at the front of the ROV of MBARI's mini ROV, and so you're not just like looking at the ROV. When you put on the headset, your views are directly linked to that VR camera, and so you're like looking through the eyes of the ROV.
Okay, I think I was mistaking that thing that the hand is trying to grab as the ROV. That's not the ROV. That's just something.
There are auxiliary
that's not the
cameras
ROV.
that are
Okay.
also on the ROV that we've added into our application. There's rectangles to the bottom left in general that show different views from different angles, but these are the main two.
Yeah.
Are there like 360-degree cameras? They don't give you stereo, but I imagine that'd be pretty cool to like be able to switch to that view and just look all around you in VR. Or I'm going off.
You might be able to get stereo from that. But both these cameras, they're like these two fisheye 180-degree cameras, so they capture like everything up to 180 degrees, and we just basically take the video feed, do some transformations to it so that it can actually display nicely in Unity, and then that gets fed into like right camera, right eye, left camera, left eye. And yeah, 360 view would be super cool. It's definitely doable.
Mm-hmm.
Not quite there, but definitely doable.
What were the biggest challenges that you faced when working with this in Unity? And
I think I personally answer I think the topic of data pipelines, like it was challenging, I think, to get all the, we were able to develop the app And I think what hindered us for a while from our initial testing was like the app would run like on our own computer when we're just kind of testing it locally, but trying to deal with like the camera feed comes from a separate place from all the data that the ROV uses. And so trying to stitch all these different pieces together into one application, especially dealing with like latency, because like when we tested locally, we tested with relatively low resolution stuff because it's just like we're just using webcams to kind of be as like a pseudo camera feed, and the resolution of our webcams are way lower than that on the ROV. And so that was a surprise when we first plugged everything in and just saw this immense lag.
Yeah. Another challenge was just getting the actual like VR view to work properly in Unity, because that's not something that it's kind of expecting you to do. That's not a super common thing. So we had to write a custom shader to actually take in the two different camera feeds and kind of project it so that one eye would see this kind of skybox for the left camera feed, and the other eye would see this kind of skybox for the right eye, and the image wouldn't be warped and all that stuff. So it seems like we should be wrapping up soon. So any last questions? Go for it now, and we can quickly try to answer them. Otherwise, feel free to just go and check out other projects.
I was wondering if you thought about adding anything else, like maybe the temperature of the water change the color that they're seeing slightly, or if the current is going really fast, change something else so that they can visualize it quickly and know what they're doing. Like, especially if someone is moving through the water, you might want to know the flow rate of the water around you.
Yeah, that's a really cool idea. So we mainly did these different these different like overlays and that kind of thing. It didn't play too much with the kind of like an overall. Like an example that sounds in line with what you're saying is something like, oh, there's a all of a sudden all of the light changes because you're like close to hitting an obstacle or something like that, which is not something we really looked into, but that would be a really cool area to explore into. And actually a kind of interesting byproduct of the lights on the ROV that you can see in the top left is that we kind of did have some like ambient, like the light would kind of change if you're too close to things, but that was like an emergent thing. We didn't design that.
And the other thing I'll add real quick is that the features that we did develop were kind of informed by what the pilots generally said that they would like to see. And we sort of prioritized which UI elements we worked on first based on that sort of like wish list in a sense. And there's definitely other items on the wish list that we didn't get to tackle. And I think whatever Lucy described just now about having something kind of like low red as we get close to it is one of those examples. And there's definitely like others that we just haven't gotten the chance to implement. But yeah, thank you for your question.
Thank you.
Great job, guys.
Awesome. Thank you.
Thanks for coming.